Let's start by creating a new table called users. I'll go ahead and paste this in. And we create a table by using the keywords create table and then the name of the table. The columns that we'll have on this table will be an ID, which is our primary key. It's an automatic, unique, auto-incrementing integer that will be applied on each table row. We have a first name, which is a text column, a last name, which is a text column, email, which is also text, and then an age, which is an integer. If we run this, this will create this structure in our database, but it doesn't actually put any rows in our database. We can see this by running select star from users, one of the simplest queries we can run. This returns all rows in our table as well as all columns. By default, all rows are returned, and by specifying select star, we get all columns. If we wanted specific columns, we could specify those columns exactly. For example, just ID and email. But for most of our cases, we'll just say select star. Next, let's insert some data into our users table. To do this, we'll say insert into users, and then the columns that we want to insert data into. Since our ID column will automatically be filled in, we don't have to specify that one. So we'll just say first name, last name, email, and age. And then we'll specify the values that we want to insert. These values are ordered based on the columns we specified. So for our first name, we'll give it the value of John, our last name, the value of Smith, and then the email, johnsmith@gmail.com, and an age of 25. I'll go ahead and paste in a few more rows here just so we can have more data in our table. I'll run this, and this will insert 7 users into our users table. We can check this by running our select star from users again. Here we see all 7 rows and their data. Now that we have some data, let's get to filtering it. We filter data by specifying a where clause in our SQL query. So let's start the same way we just had. Select star from users, and we'll use the new keyword where. And to this where clause, we'll specify a condition of how we want the database to filter these rows. One of the simplest ones we can write is using the equality operator or the equal sign. So we could say select star from users where the first name is equal to John. If we run this, we get back 2 rows because there are 2 users in our table that both have a first name of John, and by default, we get back all rows that match the condition. Our database first looks at our from keyword to determine which tables it needs to fetch. It will then fetch all the rows from this table and look for a where clause. Then it will take all of those rows and check each one of them against the where clause, discarding ones that don't match the condition. Finally, we return all columns from that in our result set. So in our example, we get all the rows from users. The database then filters out every row where the first name does not match John and returns all columns for each of those rows. If we wanted to get a specific user, we could query by their ID since we know that that is a unique column. So we could say select star from users where ID equal to 6. This would give us back a specific row. Next, let's talk about some logical operators. In other programming languages, these are known as and, or, and not. Let's go back to our first query where we're specifying the first name equal to John. Here we get back 2 rows. If we wanted to get a specific John without querying based on their ID, we could add an extra condition to this query by using an and. We could say where the first name is equal to John and the last name is equal to Smith. This returns only one row because only one row matches both conditions. Here we used and an and operator requires that every condition is true. Similarly, if we wanted to find users where their first name is John, so select star from users where first name is John, or the last name is Doe, we could use our or operator to get back rows where either this condition or this condition are true. Here we see 3 of them. We have 2 Johns and 1 person with the last name of Doe. If we wanted to invert this condition and find users who are not named John and are also not named Doe, we could specify the not operator in front of these conditions. I'll go ahead and use parentheses to make this easier to read and to group these 2 conditions together. Here we have users who are not named John and are also not having a last name of Doe. Next, let's look at some comparison operators. In other programming languages, these are known as the less than, less than equal, or greater than equal to operators. Let's use these against our age column. Let's say we wanted to find users who are at least 18 years old. We'll start the same way, select star from users, where our age column is greater than or equal to 18. Here we see all of our users which are greater than 18 years old, or equal to it. Let's combine this operator with the one we just looked at. Let's try to find users who are older than 25 years old, but are less than or equal to 35. Start the same way, select star from users, where our age is greater than 25, and our age is also less than or equal to 35. Here we see that there are only two users, one who is age 28 and one who is exactly equal to age 35. Next, we can use the arithmetic operators that we're used to from other programming languages. These are things like plus, minus, multiply, divide, and the modulus operator. For example, what if we wanted to find half of each person's age in our system? We can start the same way, select star from users, and we'll return all the columns, but then we'll add another column which is an aggregate, and we'll find the age of the user divided by 2. We'll also specify an alias for this to make it a little better output, and we'll call it half of their age. If we run this, we see all the columns from our users table, as well as a new column which specifies the half of their age value. We could also try to find users in our system whose age is an even number. To do this, we'll do select star from users, where our age value, modulo 2, or where the remainder of the age divided by 2 is equal to 0. Here we see 5 users, all of them with an even age. To find the opposite of this condition, where our users have an odd age, we can change our equal to a not equals. And we can do this in two ways, by specifying bang equal for not equal, or less than greater than for the same thing. Here we have 2 users, age 25 and 35. Next, we may want to look if a value exists in a list of other values. To do this, we can use the existence operators in and not in. We'll start the same way, select star from users, and let's look where the first name is in a list of other values. For example, John, Jane, and Rick. Here we returned 4 users, each matching a first name value in the list of John, Jane, or Rick. The inverse of this can be specified by saying not in. So select star from users where the first name is not in these 3 values. And here we get 3 rows back. We can also do a partial match on our column data using the keyword like. Let's say we wanted to find users who have an email that is a gmail.com address. We can do this by specifying where the email is like gmail.com. If we run this, we don't get any results back. And that's because this string is looking for exactly gmail.com as the email. But what we can do is specify a wildcard character at the front. So this is looking for any string that ends in gmail.com. If we run this, we see that we have 1 user that matches this address. However, if we look at our users table, we'll notice that we actually have 2 users with a gmail.com address. Both John and Jane both have gmail.com, but Jane's is a capital G. And to get Jane to return our result set, we can specify a case-insensitive match against this value. So instead of like, we can say ILIKE, the same thing, %gmail.com. This now returns both users. You can specify as many wildcard characters as you'd like. So for example, we could say select star from users, where the email case-insensitive match is like wildcard J, wildcard O, wildcard. Here we get back 4 users, anything that has something in front, the letter J, something after that, the letter O, and then something after that. Next, let's look at how we deal with missing data in our system. To do this, let's add a new column to our users table, and we'll call it first paid at. This column will be a timestamp, and it will represent the first date and time that a user paid us money for our application. We could drop our users table using drop table users, and then add the new column and insert all the data. But to keep the table in place without dropping it and losing our data, we can use the keywords alter table. So we'll say alter table users, add column, the name of the column, which is first paid at, and we'll make this a timestamp. I'll run this statement, and this will add the column to our table. If we query our users table again, we'll see that we now have this new column at the end, but this column's value is filled with a special value called null. Null is a special value in databases. It's really the absence or lack of a value, and it doesn't behave exactly how we would expect it to. To illustrate this, let's look at a few simple select statements. If we say select 1 equal to 1 and 1 equal to 2, we would expect this first condition to be true because 1 is equal to 1, and the second one to be false, 1 equal to 2. And if we look at the result set, it is. Now let's try the same thing with null. If we say select 1 equal to null, we might expect this value to be false, but the result is actually null. Even weirder, if we select null equal to null, this value is also null. It helps in this situation to think of null as an unknown value. Is an unknown value equal to 1? And the answer is, we don't know. It's unknown. How about an unknown value equal to another unknown value? Again, it's still unknown. In this way, the null makes a little more sense. To query using null, we have two special operators, isNull and isNotNull. For example, let's find users who have not paid us yet. We'll do this by saying select star from users where the first paid at column is null. Here we get back all of our users because none of our users have paid us yet. To change this, let's update a couple users to have a first paid at value. To do this, we'll say update users, set first paid at equal to now, which is the current timestamp, and we're going to do it where the ID equals 1. Without this where condition, this would update every user in the table to the same first paid at value. So when you're running an update, you have to be a little careful. We'll specify this condition so that we target only our first row of John Smith. I'll go ahead and run that statement, and let's write another one. Update users, setting our first paid at equal to the current time minus the interval of 1 month. So we're taking the current time, we're subtracting 1 month from it, we're going to update that value for user where their ID equals 2. Let's do one more, and let's do the current time minus 1 year, where the ID of the user is 3. Now if we look at our users table, we'll see that we now have 3 users, which each have a first paid at stamp. We've already found users that haven't paid us by saying where first paid at is null. To find users that have, we can say where first paid at is not null, and we get those 3 users back. Now that we have this new timestamp field, let's look back at our comparison operators from before. If we want to find users who have paid us in the last week, we could select star from users where the first paid at value is greater than the current time minus an interval of 1 week. Here we only see 1 user. We could use a different interval here, say 3 months ago, by just changing our interval value that we're taking away from the current date. Here we have 2 users that have both paid us within the last 3 months. Next, let's try to find users that have paid us between 1 and 6 months ago. Instead of using less than and greater than operators, it's sometimes easier to use the between operator when dealing with dates. So we could say select star from users, where the first paid at value is between the current date minus 6 months and 1 month ago. If we run this, we see that we only have 1 user that matches this condition. There's another way to check for a value existing in a set of values, and to do that, let's add a new table. Let's add a table called posts. This table will, like the name suggests, house all the posts that a user can make in our system. It will have an ID column, a body field, and a user ID, which will reference the user's table. I'll run this and create the table, and then next let's insert some values into this table. Into our post table, we'll insert 2 posts for user ID 1, 1 and 2 right there, 1 post for user ID 2, and 1 post for user ID 3. I'll run this statement and insert those 4 values. Now let's try to find users who have a post. To do this, we can use the exists keyword. The exists keyword takes a subquery. If anything is returned from that subquery, even a row with the value of just null, the database will include that row in the result set. Here's how it looks. Start the same way, select star from users, and we want user records where there exists a record from our post table. So we'll say select 1 from posts where the post user ID matches the ID on the user table. So here's our subquery. We're checking each row in our users table and seeing if that row exists in the post table. If so, we return 1. We could return anything here. We could return null, we could return high. The database just wants to see that something was returned. If we do this, we get back our 3 users as we would expect, because only user 1, 2, and 3 have posts in our system. Similar to our in and not in operator, we can specify where not exists to find users that don't have any posts. We could also rewrite this query using in or not in by changing this to say select star from users, where the user's ID is in a list of values, and this list of values will be the user ID from the post table. We get the same result, and we can also use not in here to get users without posts, but when checking for existence, it's generally better to use the exists keyword and not the in operator. The in operator is more useful for situations when you're checking against a static list, like we did before, where we looked for users that had a specific username. So for example, where the first name is in John, Jane, or Rick. Finally, let's look at the bitwise operators. These aren't used very often, but for completeness, let's look at some of the examples. Let's select our age column as an 8-bit binary string. Let's do a bitwise and a string of all ones, or 8 ones. The bitwise and operator ands every single bit in the string with this new string, all ones. We chose all ones here because for an and operation to return a 1, both bits must also be a 1. Let's also select our age column so we can see the result between the two. We'll make this age an 8-bit binary string so we can compare them. In our first example, we only have 1 bit that's a 1, and so when we AND this string with an all 1 string, that 1 bit remains. Most of the binary operators work between 2 operands, similar to the AND. So in a similar way, we could look at our age as an 8-bit string, and we could also OR another string onto our age. Since the OR bitwise operator returns a 1 if either bit is a 1, by ORing all 1s onto this string, we're going to get all 1s as the result. There are many other bitwise operators that work like this, so look at the documentation for your database system. One operation to note is the concatenation operator, which can be very useful. For example, if we wanted to select a name field from our users, combining the first and last name, we could do select name, the concatenation operator. We're going to concatenate a string with 1 space, and then concatenate again the last name, and we'll call this an alias of name. So here we've taken our first name and our last name property and combined them together.